Good afternoon, everybody. Welcome to today's session called Getting Ahead of Sewer Overflows and Proactive Flow and Level Monitoring. And your presenters for today are David Baginski. He is the product manager with Trimble. And we have George Alero, who is also an account manager with Trimble. If you have any questions, please go ahead and type them in the box. And we will answer as many as we can in the time that we have. If we have any that we do not get to, we'll be sure to go ahead and get back to at a later time with answers to those questions. I believe that covers everything. Over to Dave and George.
Hello, I'm Dave Baginski, and I'll be joined today by George Alero, and we're presenting an overview of the technologies, both hardware and software, for monitoring overflow events and other water-related applications. Aging water infrastructure is a global challenge. The 2021 American Society of Civil Engineers report gave the U.S. wastewater infrastructure a score of D+, which indicates poor condition, approaching end of life, end of service. Although there have been many large-scale capital improvements made to the system experiencing CSO events, these efforts have slowed down in recent years. Today, many utilities lack reliable asset condition and performance data needed to diagnose the root cause of problems, resulting in the need for more chronic repair activity. In other words, water utilities are often reactive rather than being proactive. Having this data would help with prioritizing asset repairs, planning for larger capital improvement projects, which once completed would reduce the day-to-day repair costs and maintenance of the system. Utilities that have been collecting asset performance data may also be in a position where this data is siloed from their GIS and enterprise asset management system. Thus, they never realize the full value that an integrated solution can provide. Almost every aspect of utility and local government operations and asset management depends on the accurate data of network assets. Esri ArcGIS provides this foundation as the system of record for asset information. Cityworks Office and mobile applications can be used to conduct asset maintenance and cost tracking, streamlining field operations and data collection, and improving workforce productivity. Combining the Trimble Telog family of rugged battery-powered IoT recorders and sensors with Trimble Unity Remote Monitoring and Cityworks software, we are able to perform proactive asset performance monitoring. GIS asset details, KPIs obtained from the IoT system, and operational data all feed into the Esri ArcGIS and Cityworks operational insights. Taken together, users are able to create and share dashboards and insights within the organization, providing real-time situational awareness of water and wastewater systems. Our Telog IoT recording telemetry units, or RTUs, have been proven in the field over many years. The RTUs are rugged, wireless, battery-powered devices that are easy to install and cost-effective to maintain, provide accurate, timely, and reliable data with near real-time alarming capabilities. They are used to support a multitude of water and wastewater asset performance monitoring applications. This slide illustrates some of the uses for the Telog family of RTUs. On top, we see the water distribution applications. The RTUs pictured support monitoring flow using our insertion flow meter for billing and non-revenue water applications. System pressures can be monitored and damaging pressure impulses captured. Levels of tanks and reservoirs can also be recorded. On the wastewater and stormwater collection side, we have systems designed for the collection of rainfall data, reporting of open channel flow and level data, as well as for lift station performance monitoring. The data can be used to proactively detect anomalies, improving reaction time, and minimize sewer overflows, their environmental impact, and associated cost. At this point, I'm going to hand it over to George, and give him an opportunity to discuss the various RTUs and sensors that we offer for use in the collection system.
Thanks, Dave. So let's look at the different options we have for hardware to support some of the software that we have for monitoring your assets. So Telog has several sensors we can use for monitoring level in the sewer. It all starts with our Telog RU33 remote telemetry units. They're battery-powered monitors that have the latest Cat-M Verizon 4G modem installed in them, so that allows for a lot more battery power from each use. There's been improved technology over the last few years, so we are offering now the latest Cat-M modem for these applications. They use 2 lantern batteries, 6 volts. You can buy off the shelf, and they last anywhere from 3 to 4.5 years, depending on the amount of data you're collecting and the number of times that you're calling up into the cloud to send the data. With these, we can put several different types of inputs in there. Obviously, you can see we can input Modbus, we can sample every 5 minutes, and collect all sorts of other systems and signals and different inputs into the RTUs. They're IP68 rated. So for the life of the sensor, we have an IP68 rated. We have seals on there that protect them for use in very harsh conditions, such as that you find in sewer systems, stormwater systems, even in industrial applications as well. Our first sensor that we're going to talk about is our UT35U. That's an ultrasonic level sensor, and that mounts anywhere in a manhole or in a structure, and shoots out an ultrasonic sound beam, reflects it off the level of the flow of the water, and times that sensor reception and calculates the total level for you of the fluid or the substance that you're monitoring. And these can be placed anywhere from 4 inches up to 13 feet away from the water level themselves. Next slide, please, Dave. So what do we have for the level and flow monitoring? So we have the level monitoring that I discussed with the ultrasonic sensor. We also have an option to install an AV sensor, which has a built-in pressure as well as velocity readings. So you can track your flow all the way up to the top of the manhole. So if you have any surcharge conditions that you need to keep track of and be aware of, using that sensor allows you to be able to monitor surcharge and even overflows in your system. Along with that, we also have a contactless flow and velocity monitoring system. That's what you see in the center photograph there. That is our Raven i2 velocity sensor. It's a unique radar sensor that measures velocity in the flow. And we teamed that up with our ultrasonic sensor, which is what you're looking at on the left side there, to give you the flow of the actual sewer itself or the stormwater system, whatever you happen to be monitoring. Next slide, please, Dave. So let's talk a little bit about the Raven i2. It's our non-contact, open channel, smart radar area velocity flow sensor. It's a very technically advanced radar system. We have several patents that we hold with the Raven i that we'll get into a little more detail a little further on. And they're designed for flow measurement in just about any sort of system you can have out there in the world. We can monitor both your wastewater and your stormwater collection systems. They're great for monitoring wastewater treatment plants, both the influent lines and the effluent lines from the treatment plants. In the photograph you see there on the bottom right, that's installed at an influent line at a treatment plant. So they're very, very flexible in where they can be used and how they can be installed. They're good for use in industrial discharges. Because we don't come in contact with the flow itself, that allows us to be able to measure all sorts of flows from processes from industrial applications, whether it be caustic solutions or acid used in certain processes. Because we don't touch that flow, we can monitor that from topside. And they're also used in rivers and stream gauging as well because of their flexibility with the range that they can measure at. They're very, very accurate very useful for that application. Next slide, please, David. So what are the advantages of the Raven i2? We'll get into some details here. They're great for high solids content. Once again, because we're measuring off the surface of the flow itself, we don't actually need to be in the flow, so we're not affected by contents of the solids, debris, silt that may occur in certain sewer systems. So we don't have any issues with that. Great for high temperature. Once again, because we don't touch the flow itself, we're not prone to any issues with high temperature affecting the signal or the sensor itself. They work in shallow flows. We can measure anywhere from 1/4 inch and up. So it's very flexible for very low flow applications, small pipelines, things of that nature. They're good for high velocity flows as well. We're capable of measuring up to 50 feet per second with the Raven i2 on the velocity side. Really good for large open channels, as I mentioned. We can measure up to 49 feet away from the actual flow surface. So that allows you to measure in very large pipes, maybe interceptor systems, river gauging, as I mentioned. These can be installed over a bridge and still measure the velocity of the stream or the river without any issues. And they're a key component of our Trimble water flow monitoring kit. Next slide, please, David. So let's get into some of the details of the key features of the Raven i. So we really reduce the amount of maintenance that is needed to maintain their accuracy and their lifespan. So because they don't touch the flow, we don't come in touch with that, we're reducing a lot of that, and we don't have to worry about being affected by the different things that may be present in the sewer system. We have a very quick measurement cycle. It takes about 25 seconds to complete. And each cycle measures up to 32,000 readings for a very accurate average velocity. We take all those 32,000 readings and average them out and give you your average velocity, which is a lot more than most of the competition. And we have an accuracy plus or minus 5%, which is an industry standard. We have low power consumption compared to other sensors of this kind, and we can expect to get a battery life of over 12 months. And again, it's IP68 rated. There are no seals or joints or anything to replace in the Raven i unit. So those things will be IP68 rated for the life of the unit. Reduces the amount of maintenance and servicing that's needed to keep these things operating in the sewer. And we have an internal diagnostic system that helps us to track the health of the monitor itself. We measure both the pressure, the humidity, and the temperature. So if there are any changes in that, we can track that and be alerted of these issues and react to those before they become any problems with the sensor itself and the accuracy. Next slide, please, Dave. They're very easy to install because of the way they mount with the unique mounting bracket. We can install those in just about any sort of structure that you have. They can be spun around 360 degrees to be able to measure in good hydraulics in the system. So the personnel installing these have minimal contact with the flow. There's no need to get into the pipes themselves, so that eliminates a lot of issues with safety and health. So one-time entry bracket is available, so it can be removed after it's installed to reduce the amount of service and manhole entries that are needed. And one of the patents that we hold is a self-calibrating system. There's no calibration required after the initial install, so that reduces your service and time needed to maintain these systems over the lifetime of those sensors. And we use a very unique velocity distribution analysis. And we actually use self-learning technology and AI to be able to calculate the average velocity for the life of that sensor. Next slide, Dave.
Thank you, George.
Okay, Dave. Thank you.
Coming back on here. Yeah, so next I want to talk a bit about the Unity Remote Monitoring, our software package. So data collected from the Trimble Telog RTUs and sensors feed into our Trimble Unity Remote Monitoring software. Unity is a GIS-centric cloud and mobile software solution offering advanced workflows, analysis, and reporting tools to proactively monitor asset performance, report anomalies that could result in infrastructure damage, disruption of service, and increased environmental impact. The software empowers your organization to respond quickly and effectively, reducing operational costs, improving regulatory compliance, and protecting public health and safety. You can quickly gain access to performance data and visibility and awareness in just a few steps. First, by using the Trimble Unity mobile application to install the Telog RTUs in the field, then setting up the sampling and recording intervals, defining alarm thresholds to detect operational anomalies, and configure how those alarms are subsequently managed. Additionally, you can define performance KPIs and link them to your GIS assets. The KPI results will be directly accessible from your GIS assets for use in custom dashboards and reporting tools. Finally, you can use the built-in reporting and analysis tools in Unity to monitor your distribution and collection systems. And we'll be doing a demo of Unity in just a few minutes. By combining Unity remote monitoring and Cityworks AMS, Trimble has brought together something unique to the marketplace, a solution that combines the asset performance data with the rest of the asset information. Together, these tools can be used to monitor system health with dashboards, create telemetry reports to display the IoT data, configure and track alarms, automate the creation of work orders and inspections in Cityworks directly from the IoT data, and integrate the calculated KPIs with the underlying GIS assets. By including other asset information such as age, material, history of repairs, and using Cityworks operational insights, we can calculate the probability of failure, the consequence of failure, as well as the business risk. Trimble Unity's direct GIS integration enables Esri tools such as ArcGIS dashboards and ArcGIS insights to be used for building cutting-edge dashboards to summarize and share asset performance data, as well as data visualizations that rely on spatial analytics and asset history. Trimble's integration then of Cityworks, Trimble Unity, Telog IoT, and ArcGIS products has created a unique, comprehensive digital platform with real-time asset intelligence, workflows and analytics that help you gain better insights into your asset performance, shifting focus from reactive to proactive asset management, reducing infrastructure failures and repair costs, and improving customer service and responsiveness. The use of real-time performance data to support business risk assessment and help you make informed decisions when prioritizing repair activities and easing the regulatory compliance efforts. So with that, what I'm going to do is jump into the demonstration. So this is the Unity login screen. We'll start that. You have the option of logging in using the Trimble identity, or you can use ArcGIS identity, which is required if you also want to integrate web maps and dashboards within Unity. Once you log in, you're presented with a screen of all your remote monitoring sites. They'll populate on the map. You'll see a complete list on the left-hand side. You also have access to your RTUs, Cityworks work orders, and inspections directly from the main screen. As you click each of these, you'll see the items change in the left-hand side. Going back to monitoring sites, we can take a quick look at the GIS integration and see all of the layers that are included in our web map. We have the option of turning various layers on and off, and also making selections to control how selections on the map operate. Now going over to the left-hand side, we can set up filters to filter what we see on the map at any given time. I'm going to create a filter here that shows just the in-service hydrant pressure recorders. This will reduce the number of sites that we see, both on the map and on the left-hand panel. Once we create a filter, we can save it by giving it a name. Filter can also be set as your default view when you first log into the software. Once it's saved, the menu will provide access to all your saved filters, and you can also manage them from here if you want to set one as your default, or say delete some that you no longer need. Now let's select one of our HPR sites. We'll select the Aurora site, and then we'll click on View a Default Report. The default report here is going to show both the pressure data in red and temperature data for the last 7 days. We can control the range that we see by dragging the sliders on the overview chart at the bottom. We can also zoom into a particular range by using the shortcuts, such as 1 day or 1 hour. Furthermore, we can use the cursor to draw a random box and zoom in just to that location. Now, I want to pause here a second and just point out what you'll see is a shaded area. That shaded area is actually showing us the range of data for this interval, what the max and min values were, and then the line is providing the average reading for that same interval. If we click up and bring up the impulses panel, you'll see that there was one impulse that we have in this view. Clicking on that impulse actually loads the high-speed pressure data. So now you can see within that shaded region exactly what happened. The RTU, the HPR RTUs can sample up to 256 times a second, and we can save that high resolution data for events. And then the zoom controls also allow you to back out to the original report period. So leaving this view, we can go in now and select a set of multiple pressure sites. We'll select 4. And now we'll view the default measurement. In this case, all we're going to see is the pressure data. So we'll have the pressure data from the 4 different sites. They'll be overlaid on the same chart for easy comparison. And you can see in the tooltip that you can compare the values. In addition, you can turn on the tabular data in a split screen view and see both the graph and tabular data. The summary panel will calculate the min, average, and maximum pressures for the period that you're viewing. And there's also a number of other options that you can go in and customize the report, the look and feel, turn things on and off. And finally, you can export the data that you're viewing in a variety of different formats. Now I want to show that you can make a selection directly from the map. When you click on the map, all the assets under where you click are shown in the left-hand panel. You can go into any one of these assets and click it and view the information about that asset. Now, this is a monitoring site also. It's the same one. What I want to do is show some of the information that's available under the monitoring sites, such as the alarm history. Now, from a particular alarm, we can click on it and bring up the data for that alarm. So what we see here is the pressure data. There's a dip in the pressure data, and on the lower part, there is a bar indicating the period of time for which the low pressure occurred. Bringing that up, we have some options such as annotating the report. So if we select this time range, we can then apply an annotation to the data. Say we know that this is when there was a fire flow test in progress, and we can attach that annotation with the data itself for reference in the future. Annotations can be toggled on and off. Once we return to the site properties, there is another panel for annotations, and our new annotation will show up in that panel. Clicking it will bring us directly back into the chart with where that event occurred. Below annotations, we have a section for attachments. Within the attachment section, we have folders that can organize those attachments. If we drill into the site information here, We can bring up any documents that we may have attached to the site. Now, it's important to point out here that attachments are also available on the mobile platform. So when you're in the field, you can also have access to this information. In addition, you can take pictures at the site and then upload those pictures as new attachments. Now we're going to move up to the KPIs that I was speaking about during the earlier part of the presentation. So right here, what we're looking at is the daily average pressure KPI, and the value is 76.87 PSI. Now that value was calculated for the previous day. And what we do with that value is we define which assets that value should be associated with. So as we drill down into our asset tree here and go to the water mains, you'll see that there's a single water main that has been selected. Looking on that will show us the water main segment on the map and the properties for that segment. And this is essentially how we link up then these KPIs with fields within the GIS data. So within this water main asset type, there is a field for storing the average daily pressure that has been added. And then you can map this KPI to that field. Likewise, there's also fields for storing the max and min pressures, as well as information about the number of impulses that have occurred in the previous day on this particular pipe segment. So now we'll jump down to the reports. In the reports, anytime you create a new telemetry report, you can adjust it and save it, and then it will show up in this area for faster recall. In addition, there's something called a tabular report here. Tabular reports are really summary reports. So they summarize data. In this case, we're looking at the daily summary report, which is showing us roll-ups for individual days, the daily min, the daily average, and the daily maximum. We can control the date range very easily by selecting directly from the control here which date that we're interested in seeing. At the bottom of the report, we get summary information for the entire period, and it will also tell us, when the maximum, when the minimum occurred, and how much data we might be missing. 100% means we have all the data. Anything less than that indicates that we might be missing an interval. And this data can also be exported. So I'm going to jump to a lift station. Lift stations have a default report as well. It's going to be different than your pressure report. Here we're showing pump activity, turn-ons and turn-offs, as well as level data. Now, this is a little harder to consume than the tabular report that we have for lift stations that summarizes the activity. So within this report, you'll see pump 1 and pump 2. And for each day, you'll see the total number of starts, the average runtime, as well as the total runtime for each pump. And this makes it very easy to check the performance of your pumps to make sure that they are well balanced. You should see that each pump runs the same number of times and averages the same on time. It's the case here. All right, I'm going to jump into the dashboards. I just want to give a quick overview of our built-in dashboard. On the top, we have alarm information. Under active alarms, we can see any sites that are currently in alarm. There's also an alarm history that will show the last 7 days. Clicking on any of those days then will take us to the alarms that occurred on that day. A couple of widgets to help us manage our RTUs. For example, battery replacements. If we click on critical batteries, we can see the sites that need a battery replacement. Selecting those allows us to create a work order directly from the software. We can set the battery replacement work order type, and then the assets or the sites will be attached to that work order. And likewise, we have a call status where we can track RTUs that aren't calling. And then if we're doing impulse monitoring, we can get summary information about the impulses that have occurred recently. All right, so we'll exit the dashboard and move on lastly to the wastewater flow site. We can search for it by name, select it. Now, when we get to the site, I want to quickly go into the RTU configuration. This is key for how our system works. So we can go in and edit the RTU. Here you're presented with a dialog where you can set the communication schedule, the channels, sample rate and recording information. And then below that, we can customize alarm details. So here we have 2 alarms configured for D meter, which is our depth. We have a high alarm at 66 inches and a high alarm at 132 inches. Now these 2 depths correspond to the pipe height and the manhole depth. When an alarm occurs, the RTU will call in, report that alarm, and then we can take some actions based on that. First is the distribution list. Who should be notified of that alarm? And you can create a list with emails and SMS phone numbers, and a notification will be sent out to all the people in that list. So the North District list would receive these alarms. And then under the events, we can configure what else should occur. So these are all Cityworks work orders or inspection types. And we're going to select overflow because that's what this would be. And then once we select overflow, we also then select which assets need to be part of the Cityworks work order or inspection. And here we just select the manhole associated with this site. So once we've done that, if we go in to the site and we bring up the default report for this site, what we'll see here is recently there was an event caused by a storm. It resulted in very high levels and high flows. We can turn on our alarm indicator to see that we did in fact have alarms on the D meter or depth measurement. Here I'm going to search for the manhole depth and turn that on as well. And zooming in here on a small region of the chart, we can see indeed that our level exceeded the manhole depth. And going down to the alarms and hovering over the alarms, we see that there was a high alarm that occurred. Now, as you recall, when we set up the RTU, we had set it up so that high alarms trigger an overflow work order. Going to the work orders panel at the site, we will find a work order here. Clicking on that work order shows us that we have created the work order. There is one asset associated with the work order, and that is the manhole that we had selected. And in the comment section, you'll see that this work order was triggered by Trimble Unity and a high alarm that came from this site and the measurement D meter. So this is the automatic creation of work orders that I was referring to. We can turn on the work order layer here and actually see the work order itself on the map. So this is a demonstration of how you would deploy the IoT devices, configure them for anomalies within the system, and then take those anomalies and take some action based on those. In this case, generating a work order that could be dispatched to the field for field crews to go out and investigate and do any work associated with that order. So that ends the demo. I just want to, in closing, mention that Denora is doing a session on operational insights in the next session. That would be a great follow-on for this session if you are looking for another session to attend. And with that, we'll close it out with any questions.
Thanks, Dave. We are actually out of time, so we will make sure that we got all of your questions sent to our presenters and they'll be answered by email. But we did have some great questions come through. So I hope everybody enjoyed it and has a great rest of their day and enjoys the rest of the Cityworks user conference. Thank you.